Hello, my name is Dennis Burrell, and I am a Senior Product Planning Manager for Antennas at Ventive. And today I want to present to you a R-friendly concrete raised access floor tile. So for my overview, I'll start off by talking about our original floor tile design. Then I'll move into our new floor tile design, show some test results, and then a conclusion. So let's talk a little bit about our original floor tile design. This slide right here actually shows a floor tile that has been designed by us that embeds an antenna into the concrete floor tile. It's your standard 24 by 24 inch floor tile, but we embedded an external antenna into it. The picture in the center actually shows the floor tile so you can see underneath of it. And as you can see, you see the cables that come through and connect to the access point. And then the picture to the right shows the deployment of it with the floor tile with the concrete over it. So you have an aesthetic solution, no one knows it's there. So how did we come up with this design and construct this floor tile? So we worked with one of the major manufacturers of floor tiles in the US. And we came up with this solution where we etch out part of the concrete floor tile and we embed our antenna on it. We cut out the holes for the cables to fit through. Now, depending on the access point you use, these could be 4 cables, 6 cables, or even 8 cables. We have designs for each of those. Once the antenna is in, we put a resin over top and we let the resin harden so that the antenna is perfectly flush with the concrete floor tile. Now, what I want to mention about this is that with this floor tile, the load characteristics with the antenna embedded is the same as the load characteristics of the standard floor tile without a antenna embedded into it, which was a major selling point for these floor tiles, that we could maintain the load characteristics of the floor tile before the antenna was embedded into it. Now, here are a couple of deployments of of our floor tile solution. So now let's talk about our new floor tile design. So now that Wi-Fi 6E is available and a lot of users are migrating to Wi-Fi 6E with their deployments, 6E only allows, for now, use of access points inside buildings with internal antennas. So what happens to companies that have standardized on raised access flooring with embedded external antennas as they want to transition or move to Wi-Fi 6E, where the access points have internal antennas? So what we have here is your raised access flooring. In the bottom right, you can actually see the flooring deployed and a cutaway where you can actually see under the floor. Now, what we've done is we've come up with a design where you could take an access point with internal antennas, mount it under the concrete floor tile, and get radiated performance through the concrete floor tile, hence the R-friendly floor tile. So how is this constructed? So we worked with that same manufacturer again of raised access flooring, standard 24 by 24 inch floor tile, concrete on the top. And on the bottom, instead of having steel plate throughout, what we did was we cut what we call R-friendly windows into the steel on the bottom side of the floor tile. Now these windows, they're 9 windows, 3 inches by 3 inches, that cut away, the steel is cut away, so it's just bare concrete. And when the access point is placed under it with the internal antennas, it can radiate through the bare concrete. Now, the reason why we chose 3 inch by 3 inch windows is because at 2.4 gigahertz, we can get good radiation characteristics at half a wavelength through these windows. So therefore, since 5 gig and 6 gig are higher frequencies, meaning they have lower wavelengths, they'll radiate efficiently as well. Now, the side view actually shows the concrete with the steel plates and the windows cut out. What we do there is we place the access point below those windows. and an adjustable tray. And let's look at that. Now you see the bottom view with the windows and the access point bracket where the AP sits into it. The side view shows it as well. To the right is an actual bracket design that we came up with where the AP sits on the bracket, and that bracket can be raised or lower to optimize the radiation through the concrete of whichever access point with internal antennas that's being used. So let's talk a little bit about some test results that we did to see how this raised floor tile with the RF-friendly windows worked. So we did a little EKAHAU predictive survey where we took a 9130 AXI internal antennas at 5 gigahertz with 12 milliwatts of transmit power, and we put the AP on the ground pointing up with no attenuation. And as you can see, you see the radiation characteristics of this AP. For scale, we used a football field. Next, we did the same thing, 9130 AXI, 5 gigahertz, 12 milliwatts of power with the AP on the ground pointing up. But this time, we put a floating 10 dBm attenuation box to simulate concrete, and we put that 1 foot above the AP. And as you can see, from this, we still have radiation, efficient radiation through the concrete. Although the coverage is smaller, it's still good coverage. Now, what we're currently doing now is working with some customers to do some more testing on this design. And this testing will be done at 6 gigahertz. Now that there's some 6 gigahertz devices out there, we can actually do some design at 6 gigahertz to see what this performance looks like. And we're excited to work with them to see how everything works. So at a later date, I will be presenting those results to you guys. So we're very excited about that. And we're in the process of doing some designs or doing some testing. Currently, we have done some testing at 5 gigahertz using some devices, and we're seeing some good performance that's somewhat matching what you see here, or matching predictive, actually a little better. So one of the things with this was predictive was trying to get that attenuation box and the AP height below it at a specific height to optimize the performance. So what I would like to say in conclusion is that a top-down approach, which is your typical AP with internal antennas on the ceiling, compared to a bottom-up Wi-Fi approach where the AP is under the floor, it's all about perspective. I know a lot of you haven't seen something like this before. This is new to you, so you may be skeptical because you're used to a top-down design. But I can assure you that a bottom-up Wi-Fi approach works well. We've done it, for instance, with our concrete floor tile with embedded antennas, and now we're just looking at it from the perspective of using integrated antennas into the APs. But one of the things I would like to say, again, it's all about perspective. So if you look at this picture right here, do you see the tiger laying down, or do you see the tiger coming towards you? It's all about perspective. And I think the bottom-up Wi-Fi is a good option specifically for designers and companies that want a more aesthetic approach where they don't want to see anything on the walls or on the ceilings. And for Wi-Fi 6E with internal antennas, this will be a very good approach. Thank you. Dennis Burrell, Instagram, TGI Wi-Fi Guy.